Hello, in this video we'll explain the structural modeling for VHDL. So this video is a continuation of the first part, which is covering the behavioral modeling. Now we'll focus on the structural design. Just to remind you, the difference between the structural and the behavioral modeling is the following. With the structural modeling, we can describe the circuit using wiring between components. So we can declare the signals and explain how each block is connected to the other ones, or each component is connected to another. With the structural modeling, we often require more than a single file because we will need to implement each component separately or each block separately in a separate file, and then we'll need a wrapper file to explain the connection between these components. With the behavioral modeling, oftentimes we can write it in a single file and it describes the behavior of the circuit. We will need to use operators such as the AND or NOT operators and or statements such as the while statement, the if statement, the switch case, etc. Since this video focuses on the structural modeling, we'll start by mentioning or listing the steps that are necessary for us to be able to code a structural model. First, we'll sketch the logic diagram of the expression. Next, we will identify the input and the output ports. The third step is to identify the unique components that are needed. Step 4 requires us to name the instances of the components. So some of the components will be instantiated more than once. So we'll have to label them uniquely. In step 5, we'll name the internal signals, which are the wiring between the components that are neither input nor an output. Finally, we'll start coding based on the design steps that we did in step 1 until 5. So let's do an example to better illustrate this. We're given an expression that is f is equal to not k and l or not m, and we want to implement it using behavioral modeling. We'll start by first sketching the logic diagram. I use Logisim to do that. This will help me figure out what input ports and what output ports are required, which will be needed for the second step. So this is the logic diagram, that's step 1. In the second step, we'll identify the input and the output ports. From the sketch, clearly, we can tell that we have a total of 3 inputs, K, L, and M, and we have one output port, which is F. So we can list the ports as follows. We have 3 inputs, K, L, M, and one output named F. That is step 2. In step 3, we'll identify the unique components that are needed. For example, here we have 2 NOT gates, so we only need one NOT gate component, and then we'll instantiate it more than once. So NOT gate is one component. We have one AND gate and one OR gate. Remember, we want to only list the unique components. So we'll list them as AND gate, OR gate, NOT gate. Notice how these are actually acceptable or valid VHDL entity names. So this component name will be first written as an entity or defined as an entity in a separate file, and then we'll need one additional file for our structural model. So before we start with our structural model, we'll assume that these entities are already defined. If not, we'll have to define them ourselves. In step 4, we'll name the instances of the components. As we mentioned earlier, the NOT gate is used twice, so we have to distinguish between these 2 NOT gates in addition to the rest of the gates. So we'll label these gates with a different name. I'll name them G1, G2, G3, G4, short for gate 1, gate 2, and so on. So we need a total of 4 instances, 2 instances from the NOT gate, 1 instance from the AND gate, and 1 instance from the OR gate. In step 5, we will name the internal signals. When we say internal signals, what we mean is that any signal that is not an input or an output. So let's identify the inputs or the wiring for the inputs. We have K, we have L, and M. The output is F. So all the highlighted signals in blue are considered ports. So they're actually not internal signals. What is considered an internal signal is any signal that doesn't have a name yet, which are highlighted in yellow. I will name them as S1, S2, S3, short for signal 1, signal 2, and signal 3. And notice again that K, L, M, and F are ports, and I don't need to label them because they're already labeled and they have names, and they will be declared as ports under the entity part of the code. So the signals are S1, S2, and S3. Now the last step is to start coding. And of course, there's one additional step, which is testing our code. But we'll focus on the coding part of the design. This is part of a template or a syntax for the structural modeling code. We will use it as a guide to continue any structural modeling. We'll assume that the file name or the entity name is xstruct, so this must be repeated 3 times, and this will also be our file name. So the file name should be, in this case, exp_struct.vhd. This is going to be our file name. With the hint of the design steps that we did earlier, we'll continue or complete this template file. We have 3 input ports, K, L, and M. The first input has been taken care of. We need to list the rest of the inputs, so we have L, M. And these are each 1 single bit, and they're considered inputs. Okay. For the output, you only have 1 output named F. So I'm going to say F. It's an output and it's a single bit. Standard logic means a single bit. Now the entity part is complete. All we have left to complete is the architecture part. With the structural modeling, we have to list all the components just once. Every unique component that is used must be declared once. We listed in the template that is given, the AND gate is already mentioned, the OR gate as well. All we have to declare now is the NOT gate using the same syntax. So we'll say component, that's part of the syntax, so I have to spell it correctly. And then the name of the component for the NOT gate that I will define or assume that is defined is NOT_gate. So I'm going to continue with that. I'll say component NOT. I'll use a different color. Component, maybe green. NOT_gate. Now the port line must be exactly the same as the way I declared the NOTgate.vhd file. Just to help me be more consistent, I will always use A, B, C, D, etc. as inputs, and as an output I'll use Y. This is the case for the logic gates files. So I'm assuming that the NOT gate is declared with A being as its only input, colon in, and it's a single bit, so I'll say standard underscore logic, semicolon, because I want to now list the output. I have a single output, colon, it's an output, and it's also a single bit, standard logic. Remember to close the bracket for the port, semicolon, and lastly you have to say the word end component. End component. And semicolon. Okay, now this is complete. The next part is to mention all the signals that are needed, or the internal wires. We already have S1 labeled or mentioned. I have to declare S2 and S3. So I will say comma S2, comma S3. And we have a colon after the third signal. Let me make that a bit clearer. So we have S2, comma S3. Now in the last part, after signal, we have to say the keyword begin and then end struct, which is our architecture name. And in between, we have to do the mapping of the wires to tell the compiler that G1 is actually a NOT gate and it connects K as an input and it outputs S1. So this is what this line of code means. We have this instance and it's called G1, and G1 is actually a NOT gate. Port map is part of the syntax, and you have to list the the signals in the correct order. And the NOT gate, the input goes first, that's why K goes first, and the output is the second signal. So that's why I put S1. And if you notice in all the gates, it's the same. We list the inputs first and then the output. So regardless of the name that I chose here in the component, I will always use whatever names I have here, but I have to put them in the right location or in the right order. So I'm going to start declaring my second gate. I will say G2. What is G2? G2 is actually AND gate. So I will say AND underscore gate, the exact same way I declared it as a component. The keyword port map, two words, brackets, now gate 2 takes S1 and L, and it gives me S2. So I have to list the inputs first, S1, comma, L. The output is S2. Close the bracket, semicolon. We're done with gate 2. Now gate 3 is what? Gate 3 is actually OR gate, I can tell from the symbol of it. So gate 3 is an OR gate, OR underscore gate, the keyword port map. This OR gate takes, I will highlight it in purple, takes S2 and S3, and it outputs F. So S2, S3, comma, F. F is my output and it's listed as a port, and I define it through gate 3. There's one more instance that I have to declare, which is gate 4. So gate 4 is actually this AND gate. So I would say AND underscore gate, keyword port map, and then open a bracket, close it, semicolon. Then look at gate 4. Now the last gate that I will have to declare is gate 4, which is actually this gate. So it's a not gate, not underscore gate, port map, open a bracket, close it, put a semicolon at the end, and then we will have to define the port mapping for G4. We can highlight them first. I'll use orange. So G4 takes M as an input and it outputs for us S3. So I'm gonna say M, comma, S3. Now this is the complete code for the expression underscore struct.vhd. But remember, without these files and underscore gate.vhd or underscore gate.vhd and not underscore gate.vhd, this file will not work because it uses these as components within it. So as a structural model, I have to define each of the components in a separate file before I'm able to use them. So when we simulate this file, we have to make sure that the other 3 files are available, and we have to test them first, make sure they work before we're able to use them. This is all there is for this video. I'll have a separate video explaining how we can simulate our structural code and verify its accuracy. But keep in mind that with structural code, if it's possible for us to implement it using behavioral modeling, which is the case for the expression that we just did, the truth tables of both files should be exactly the same, because we're at the end of the day doing the same thing using 2 different design or 2 different methods. This slide summarizes the settings you need to adjust before using EDA Playground to test your VHDL code. So remember to change the language to VHDL, type test bench under the top entity, choose LDIC Riviera for the tool and simulator. Make sure to tick the box where it says Open EP Wave. To confirm that you're using the right language, you'll see that the extension should change to .vhd. This is the code that we assumed for the structural modeling for the component not gate. For the OR gate component, this is the file that we assumed. Notice how the ports are declared as we used them earlier. It's A, B, and Y as the output. Similarly for the AND gate, the name is AND underscore gate. The inputs are A, B, the output is Y, in that particular order. And that's the final code for the expression structural, which is not K and L or not M, after typing it on the computer.